that emits light and creates charge when particles pass through it. It's actually we're not sensitive to the light spectrum, but what we'll do is collect the light that's emitted using a light sensor, which is right here.
Okay.
And we'll also collect the charges that are knocked off of the molecules in the liquid.
Okay.
And we'll use those two things to determine the energy, the position, the direction of the particle passing through it.
Okay.
And
so all the hardcore physics that we study in like the school things, like the the discovery of electrons, stuff like that. That type of experiments that you do.
In some sense, but like those are very
basic
fundamental.
Ones. Yeah, exactly.
Those were, massively impactful experiments.
Yeah.
And oftentimes the flow of research in our small scale labs is to build experiments that demonstrate a particular technology works, and then to scale that detector technology up until oftentimes your sensitivity to new and interesting physics comes from scaling a technology to be very large and also very expensive, such that one lab wouldn't really be suited for it. But we can demonstrate the detector technologies in smaller setups like this, and then show, hey, there's maybe a new type of particle detector that we can use to measure such and such and such. So in this case, the detecting medium you can see is dripping down right here.
Okay.
So this all of the tubing here is a circulation system where this chamber here is filled with liquid, and we thermodynamically set the temperatures of different spots here such that there's a circulation of vapors that evaporates on that side and then condenses here. And what that does is it sets up a flow through the piping, and then you can put purifiers in the piping that cleans the material, because one of the plagues of detecting particles is impure detection medium. If there's impurities, the charges and the light gets lost.
Yes. And it can it can be of different color if there's an impurity.
Well, it's mostly all the same color, and it's all UV. It's not even really. Oftentimes it's UV. It's not detectable.
And this is like insulated for thermal insulation. Okay. Perfect.
So, but the impurities will generally just lower the amount of signal you detect. And sort of tying it in with electronics, the number of charges, the number of electrons that we're actually collecting and then trying to amplify to turn into a signal on an oscilloscope, for example, or some other digitized system, is in the thousands to hundreds of thousands of electrons alone. So these are, pretty small integrated signals. Essentially, our noise, the noise on the amplified signal needs to be on the order of 200 electrons equivalent noise current. So anyway, the point is, you can see that to get the signals out, there's a lot of electronics needed. There's a lot of custom electronics as well. And so we'll work with electronics engineers to design these custom electronics. Oftentimes they're not really used anywhere else because we're building very specific detectors that have a specific set of needs. But all the time, the physics detection technology and the electronics technology are being developed in tandem, and they are both difficult. So it's not always the case that the electronics is going to be easy. In fact, actually, it's usually the case the electronics is going to be very hard.
Yes, exactly.
And so we will work with professionals very heavily, and we'll also develop our own electronics as well.
So you have done like bachelor's in physics and then master's in physics.
Just like bachelor and PhD,
Nice.
But
PhD is like a long, how is PhD?
it's anywhere from 5 to 8 years. I did it in 5 years. But,
Okay. Like after bachelor's, you did like master's and PhD in 5 years.
Yeah, the
Okay.
two together, I guess.
Okay, and now you are doing a postdoc.
Yeah.
Oh,
Yeah.
so you are really into physics and research.
yeah. This is sort of my life. So
Okay.
yeah, I like doing this sort of thing and plan to make a career out of it. But yeah, so this is one lab space. It's sort of pretty messy.
So you don't teach right now.
I don't teach at the moment, but I
Okay.
do mentor students in the lab. So
Okay.
we'll have it's a collaborative effort amongst people of many